Okay, so today we're talking about representing quadratic functions in three forms, and we've discussed how these three forms tell us different things about the same function. It's three different ways to represent or to show the function, but they're all showing us different, all these forms are showing us different things, which we can then use to graph the function very effectively. So in this first one, we are now given the standard form of this quadratic function. We have to convert this to vertex form, and then we have to convert it to factored form. Now, first of all, let's determine what this standard form tells us about the function overall. First of all, it tells us whether it opens up or down. So what does this open? It opens down. Second of all, the C value, which is this last term here in standard form, tells us the y-intercept. It is the y-intercept. So the y-intercept of this function is equal to 6. So in standard form, these are basically the two things that the formula or the function itself tells you when it's in standard form. Alright, so now let's find vertex form. We've learned that when we do vertex form, we have to use the completing the square method to convert it to vertex form, and we have to focus on the x terms. Yes, so we got to factor out this negative 2. It can be factored out. Anytime you have a number in front of x squared, you've got to take it away.
Wait, is there a GCF?
Well, it is kind of like a GCF, but it's not officially a GCF. The whole GCF would be negative 2x, but we don't want to deal with our x's. We only want to take away the a value and pull it out. So we did that. So negative 2. Now, what's left? That leaves x squared plus 2x, and then plus blank, and then plus 6 with a blank. All right. So we're almost done completing the square. So we got to take half of 2, which is 1. And 1 squared is 1. Now, that's not really a 1. It's really a negative 2 times a 1, which is negative 2, right? So what am I going to do out here?
Add 2.
Add 2. And that will become positive 8, yes. Alright, so now we can write this as a square of a binomial, so you'll have your negative 2 times x plus 1 squared plus 8. Now it's in vertex form. And when a function is in vertex form, it tells us the vertex. So the vertex here is?
Negative 1, 8.
Yep. It also tells us the axis of symmetry,
which is negative 1.
Alright, so we've got our standard form, now we've got our vertex form, and then to do our factored form, you have to go back to standard. Everything comes from standard. You have to go back to standard and factor it. Now, the first thing we do when we factor is to look for a GCF. So what is my GCF here? 2. Negative 2. Let's factor out a negative 2. That's going to leave x squared plus 2x minus 3, because I'm dividing it out. So negative 2x squared divided by negative 2 is x squared. Negative 4x divided by negative 2 is positive 2x. And then 6 divided by negative 2 is negative 3. Alright, once we have the GCF, we can now break this into two sets of parentheses. So we'd have x and x.
Plus and minus.
Plus minus. And then what are the factors of 3?
1 and 3.
1 and 3. So, where does the 3 go?
It looks like the 3 goes to the positive side.
Yes. 3 goes with the positive, because I want a positive 2 in the middle, so 3 minus 1 is 2. That works. We're done with this. This is done. This is in factored form. But what does the factored form tell us?
It's the opposite.
It tells us the zeros, roots, solutions, x-intercepts.
Yeah.
Okay? So, in this case, x is equal to what?
X is equal to negative 3, 1.
Negative 3, positive 1. Now, I do want to clarify that these four terminology, all mean the same thing, but it's in different contexts that we use these terms. So, in other words, like if, y'all know Master Sergeant, right? Okay? Well, at school, I'm going to call him, in front of students and everything, I'm going to call him Master Sergeant. Because that's his professional name, right? But if I know Master Sergeant, out in the town, I'm probably going to call him by his first name. His friends would call him Damon. That's his first name. Okay? If y'all called him Damon, it would not be appropriate. Okay? That would not be appropriate. So, the point is that he is the same person, whether you call him Master Sergeant or Damon. These are the same things, no matter what we call them, but we use different names in different contexts. If I'm dealing with function notation, I'm going to use x-intercept or 0. If I'm dealing with an equation that I have to solve, like equals 0, something equals 0, I'm going to use the words roots or solutions. So they all mean the same thing, we just use them in different contexts. Alright, now let's graph it using all things that we have. First of all, let's start with our vertex. So, -1, 8. Next, let's do our y-intercept, since that's a number that we can graph. What is it? 6. So go up to 6. 1, 2, 3, 4, 5, 6, right here. Now, if the y-intercept is 6, notice that it's on the right side of the vertex. What would that mean? That there should be a point over here on the left side of the axis of symmetry, right? So there should be a point right here. Does that fit our A value? Yes, it does. Our A value is -2, so we would have gone down 2, right 1, down 2, left 1 in the same way. Now, does it always work out that way? Is your y-intercept always going to be the same as your A value? No, it's not going to always work out like it did here. It just so happened that it worked out here. Now, the next thing we can graph are the x-intercepts. -3 and +1. So we've got 5 different points that we were able to graph just by knowing the different characteristics of these functions, of this function in different forms. So then we can graph it. This is a very accurate graph.
Yes.
And even though I didn't draw it very well.
Wait, what's the fifth?
Okay? Alright, now, this next example goes from vertex form, and we've got to convert to standard form, and then from standard to factored. We always have to go to standard first. If standard is not given to you, you have to find it. And then from that, you can do factored form. Okay, so how are we going to convert from vertex form to standard form? Very simple. Use the FOIL method. Use FOIL. Alright, so here's what I mean by that. We're going to do f of x equals negative, and then you've got to expand the x minus 7 squared to be x minus 7 times x minus 7. And then at the very end, we will add in the 1. Now, FOIL method means first, outside, inside, last. So multiply the first terms together. And so the negative is still here. X times x is x squared. And then x times negative 7. Negative 7x. And then negative 7 times x. Negative 7x. And then negative 7 times negative 7. It's positive 49. And then that positive 1 is still there that we'll deal with later. Okay, now, we can combine some things in here. What is negative 7x minus 7x?
Negative 14.
Okay, so that's really negative 14x. I'm going to just write negative 14 right there. Okay, since there's a minus on the outside, that minus gets distributed onto each term on the inside. So it's going to become negative x squared plus 14x minus 49, and now I can add in that plus 1. So my final answer will be negative x squared plus 14x minus 48.
Why did you change that to a minus 49?
Because this negative that was on the outside has to be distributed You can't forget about it. Alright, now, again, what does this tell us? We know it's going to open down. You don't have to write that every time, but we know it's going to open down. We know that the y-intercept is negative 48. Okay? Don't think we can graph that. Alright, and what did the vertex form tell us? That the vertex was 7, 1. And the axis of symmetry, the AOS, is x equals 7. Alright, now, to get to factored form, we don't look at vertex form, we look at standard form. So this is what needs to be factored, but I don't like this negative in front. So what am I going to do with it? Pull it back out. Exactly. So f of x equals negative parentheses x squared plus, minus 14x plus 48. We're factoring it out. Factoring out the negative. So now, I can factor this trinomial. So what goes in parentheses? No. X and x. Minus minus. Because the last sign is positive. 6 and 8. So I've got this negative out front, which was kind of like our GCF. We don't like having a negative x squared, so we need to pull it out. Pull out the negative. And this is what was left. So, what is my x? What are my x's? 6 and 8. So now we have enough info to graph this thing. So we're going to graph 7, 1. Right? 7, 1. Our x-intercepts are 6 and 8. So let's plot those. Here's 6 on the x-axis, and here's 8 on the x-axis. And if I had used my a value, it would have taken me to those same points. Negative 1 was the a value. Alright, I don't need any other points to graph, so I'm going to just go ahead and do it. I can't, like Greg said, we can't do the y-intercept. It's too far off the graph. But it will be way down here somewhere. Way down here. Can you see that? Way down here. Alright. Alright. Okay, flip the page. Okay, I want to skip this top one because it's another vertex form conversion. I want to go straight to the factored form conversion for the video. Okay, like I said before, you always want to go back to standard form first. So, to go back to standard form, all we do is we FOIL. So, we're going to use FOIL to go to standard form. So, we're going to take this, and we're just going to write it over here in FOILed form. So, x times x is? X times 7 is? 3 times x? And 3 times 7? So, combine your like terms. X squared plus 10x plus 21. That was easy. Okay, so that wasn't very difficult. It takes more time when you go from vertex form to standard form. Okay, so now we have to convert from standard form to vertex form using completing the square. So f of x, I'm going to write that. Use completing the square. Alright, so f of x equals parentheses x squared plus 10x plus blank plus 21 plus blank. Alright, so we want to take half of 10. 5 squared. 25. And then what would I do out here? Minus 25. So, x plus 5 squared minus 4. Got that, Bobby?
Yeah.
Okay, so our vertex,
Negative 5, negative 4.
negative 5, negative 4. Our solutions, which we didn't write earlier, our x-intercepts are negative 3 and negative 7. So I have plenty to be able to graph this thing. Left 5, down 4. Okay, my x-intercepts are negative 3 and negative 7. if I wanted to use my A value is 1, so I could go up 1, right 1, up 1, left 1. So I've got 5 points to use for this graph. Now, the y-intercept is 21. That's too far for me to be able to graph it. So I've got plenty to be able to graph this thing. So the 3 forms give me different characteristics of the function, which allow me to make a really good graph. Alright, I'm going to stop the video here, and we're going to do the other ones as practice.